When you picture a volcano, you probably imagined something like this: a towering, snow-capped cone surrounded by flat land, the classic profile of a mountain like Mount Fuji. It is completely natural to assume that the largest volcanic structures on the planet follow this exact same blueprint, just scaled up to the size of a giant like Mount Everest. But our view of geology is heavily skewed by the simple fact that we live on land. The most massive physical features on Earth are completely submerged beneath kilometers of heavy, dark ocean water. Deep under the Pacific lies a colossal volcanic structure named Tamu Massif. It is a single formation that covers an area roughly the size of an entire country. Because we spend our lives walking on solid ground, we assume the mountains we can see represent the upper limit of what the Earth can build. To find the true giants, we have to look past the surface. If we want to find the largest active volcano, the answer is Mauna Loa in Hawaii. Rising high above the clouds, it is a massive, gently sloping giant. This cross-section shows the actual scale of Mauna Loa. The part of the mountain visible above sea level is only a tiny fraction of its true mass. Its enormous base begins thousands of meters down on the Pacific floor. Beneath this immense structure lies a persistent vertical column of intense heat. Unusually hot material rises continuously from Earth's mantle, providing a steady supply of magma. As the upper crust layer slides horizontally, the Pacific tectonic plate slowly creeps across this stationary heat source like a geological conveyor belt. Over millions of years, the moving plate pulls the older volcano away from the magma supply, and a new volcanic cone begins to form directly over the heat column. The lava produced by this specific process isn't highly explosive. Instead, it erupts as a highly fluid basaltic rock that spreads across the dark landscape in wide, glowing cools. Because this lava flows so easily, it doesn't pile up into a steep spire. It spreads outward layer by layer over countless millennia, building that incredibly wide, gentle slope known as a shield volcano. Mauna Loa's incomprehensible volume is the direct result of a deep mantle heat source pouring lava out continuously over immense stretches of time. Hidden largely under the waves, it forces us to rethink our basic definition of a mountain. If we travel further across the Pacific Ocean, we find an ancient, massive underwater plateau called the Shatsky Rise. This top-down geographical map outlines the footprint of Tamu Massif. The structure stretches across roughly 300,000 square kilometers of the ocean floor. To put that scale into perspective, when we overlay the silhouette of a nation like Japan directly on top of it, the volcano completely dwarfs the country. By pivoting this graph to a side profile, we can contrast Tamu Massif's incredibly gentle, nearly flat slope with the sharp, dangerous vertical spike of a stratovolcano like Mount Fuji. For years, scientists have debated the exact origin of this formation. Some research classifies it as one massive shield volcano formed roughly 145 million years ago, while others suggest it's a complex of multiple merged eruptions. When observing a geological structure built over millions of years, the sheer volume defies the rigid categories we typically use to define individual mountains. While these deep-sea structures are massive, their physical size is a poor indicator of the danger they pose to human populations. Active shield volcanoes may not erupt with explosive violence, but their massive, fluid lava flows slowly cool into thick walls of dark rock that can easily crush roads, homes, and local infrastructure. That is why scientists rely on constant technological monitoring. Seismographs detect the erratic, jagged shifts in the Earth's crust, providing visual proof of continuous internal seismic activity well before magma ever breaches the surface. Beneath the waves, magma continuously forces its way into the frigid ocean. It violently expands against the water, rapidly cooling into dark rock to build entirely new sections of the Earth's crust. The calm, flat expanse of the ocean's surface masks a restless internal engine, pushing, melting, and erupting. These submerged giants are constantly working to dictate the physical shape of our entire world.